And welcome to today's webinar. My name is Marco and I would like to present you mapping building facades for 3D representation. Super interesting webinar with a bit different tool. Most of them we use the Phantom 4 drones. In this one you will see a bit smaller version of drone, and super exciting to show you how to produce an orthophoto map from the building facade, which is also not maybe the standard way of project. Just short introduction about myself. I'm a land surveyor with more than 11 years of experience. I have also some experience with traditional surveying, mainly from first 3 years. So I know what kind of projects are you doing. So I will try to represent this webinar in this way, that you can see the high potential of this technology also with the help of these new features. I've worked on more than 1,000 projects based on photogrammetry. Those were all volume calculations, profile line calculations, contour lines calculations, survey maps, orthophoto maps, really different projects, really interesting one. And I'm also a product manager at 3D Survey. And because we also fly with the drones quite a lot to test the software, how powerful it is, to open the new doors for the software. I'm also trained drone pilot operator and have experience also from the drones. Nevertheless, during the webinar, you have options to set your questions. So feel free to write your questions in the question box, which should be on the right side of the webinar platform. And I will try to answer them during the webinar or at the end of the webinar, where we'll also have a bit of time. The complete webinar should take approximately 35 to 40 minutes. So let's start with our topic introduction. First, I would like to explain a bit about the project descriptions, what kind of project we have in this case. Then we will have a look about equipment description. We will go and have a look for instructions for data acquisition. It's a bit more specific project, and I would like to explain you as much as possible how I did it, that you can reproduce on your site if you will have that kind of projects in the near future. And then, of course, we will see the workflow in 3D Survey, how to get the results, and what kind of results can you achieve with our software. Before we go right into it, I have a really quick question for you, and this is actually, are you already 3D Survey customer? So to get a feeling what kind of audience we have yes, you are 3D Survey customer. No, I'm using another software. And then the third answer is no, I'm still new to these technologies. I'm thinking to go right into it, and so on. Okay, 70% of you already voted, so let's wait a couple of more seconds. 80% of you, 83. Okay, I think we have more than enough answers, and to inform you, 56% of attendees are already 3D Survey customers. That's great to hear. 28% using another software. Great to move you to 3D Survey, definitely. And 15% of you are new to this technology and would like to find out a bit more. Okay, I can also share those results with you, probably. Yes, no, you should see the results also. And in the meantime, let's go and start with our project description. So in this webinar, I would like to show you how we did 3D mapping of an old building, which is a part of a cultural heritage. It has a lot of small details which needs to be documented before the restoration. The construction guys ask us to deliver textured full 3D models with the highest detail as possible, and an orthophoto from every facade in a resolution of 1 millimeter. We decided to use in this case Mavic mini drone. Because the building is more in the city center. It's small enough to cover it with such a nice drone. and we can get really good results with the help of powerful software, also with a 12 megapixel camera, which is not maybe the most accurate one if you would have a really big areas. But for this approach, you will see it's more than good enough. What's also specific in this project, this drone doesn't offer you automatic flight, so we will need to fly manually, trigger camera manually, but with a bit of practice, this is nothing hard to do. If we would have 500 to 500 meters and some kind of open pit mine, this would be probably pretty hard. But in this case, as you will see from the video, from the field, it was super easy. We also set some GCP setup to orientate our model and actually to improve the scale from the model. As you already know, when the drone triggers image, it gets the coordinates, but those coordinates are not super accurate because it's not an RTK drone. We get some kind of scale of the model, but if we would like to improve this distance between objects on the building, it's great to use 2-node distances. And with this help, you can actually create your GCP file and do the standard GCP orientation in the software. You will also see everything in this webinar, how it goes. And this actually improved the accuracy on the end model. And then at the end, we need to deliver results, texture full 3D mesh and facade orthophoto with 1mm resolution. Equipment which was used in this case was DJI Mavic Mini. You can see the drone here on the left side of my screen. It's super small one. It weighs less than 250 grams. It has a small camera attached on it, which is integrated and produce actually super nice images. If you have smaller sites or smaller area, I would advise you to use something like that. If you like to go for bigger one, definitely go for Phantom 4 Pro or Phantom 4 RTK. Of course, then for orientation, we didn't use in this case the total station. We just measured two distances with the help of measuring tape. And I actually measured the height of this window and then the distance from those two windows. I could do this better to measure the brighter distance. So at the beginning, at the end of the building, for example, but I was the only one there. I was preparing this for the webinar. Later on, we will do also decently for the project. In this case, I would measure bigger distances, but just to give you an idea how it works, I did it that way. The another option would be a total station and measuring, let's say, 4 points from the building corners or from the corners of windows and use the classical orientation. And yes, at the end, we process everything in 3D survey software, and you will see the results in short. Then super interesting instructions for data acquisition. It was a manual flight, so I start the drone manually, fly in a grid mission, but not in a horizontal one. I fly in a vertical grid. So as the same as you would do classical mapping with nadir images where the camera is pointing down, just assume that you are flying vertically and you need to collect those images with the right overlap. This means at least 70%. And at the end, you will just get a perfect result, the same way if you would do the automatic flight. Of course, it takes a bit more experience, but maybe if you did already a few projects the traditional way with the drone, I'm sure you will manage to get it. And my suggestion is also rather do a bit more images than less, because you can later always eliminate the images. The only cons of too much images is that the processing time it's a bit longer, but you are definitely at the end pretty much more sure that everything will be fine and pretty detailed. And yes, let's go and share this video from the field with you, that you can see how I did actually mapping. Okay, behind of us is a super nice
old building, which is part of cultural heritage building, and they will start with restoration works. In short, before they do the restoration work, we would like to document it, the complete building with all the building facades, with a high detail. We would like to produce orthophoto with resolution of 1 millimeter and textured 3D model with all small details which are super important, and to have them documented in 3D to do the restoration work properly. Our tool for today is Mavic Mini drone, which is a super effective drone for such a small project. It's super easy to fly, safe, and so on. For orientation, I will just measure two distances in perpendicular positions and use kind of a local coordinate system. I will show you in the webinar how to do this. I could also use a total station or something like that and measure some detail points from the windows and use it for orientation, but because they don't need the accurate position, they need more or less dimensions between different objects. This method is more than effective and more than accurate enough. So yeah, let's start with the GCP setup to place the local coordinate system, and then we'll show you how to fly with Mavic Mini. What's special here, Mavic Mini doesn't have a flight plan mission who could allow us to fly automatically, but because it's just a small area, we will easily do also with the manual flight and actually manually trigger the camera. What's important here to know is to have good overlap between images. I assume at the end we will have approximately 60 to 100 images from this facade, and then of course we have 3 others to add in addition. Okay, let's start.
Fly a Mavic Mini is actually super easy. So with the help of DJI application, you have a live view from the camera. Unfortunately, this Mavic Mini doesn't allow you autonomous flight for mapping, so it's not the same way as you would do with a Phantom or any other Mavic Air or similar drone. You need to fly manually, but for such a small object, this is not a problem. As you can see, I'm flying in a horizontal way, stopping every 2 meters and just triggering images, and then higher my flight for additional 2 meters. And fly back and trigger cameras. So it's actually super simple. Just for your feeling, I'm actually about 5 meters away from the objects because I really like to have images with good quality, with high resolution, because this will deliver me at the end nice point cloud and great orthophoto.
Okay, I finished with my field work. It was a 1 battery flight, I think approximately 60 images for this building facade, and I used the measuring tape to measure 2 distances between windows, which will help me to orientate the model and get accurate dimensions between specific objects we need to deliver to our end customer. Let's get back into office, import the images, and create stunning 3D model.
Okay, so this was a quick intro from the field, how I did the mapping, and now I would like to show you what kind of results did we get from the drone. So a quick overview about images, and then we will share with you the complete workflow from images to textured 3D model, and of course also facade orthophoto, which is our main goal for this webinar. Once again, if there are some questions, please write them in a question box. You can do this also during the webinar, so not a problem. And let's start now also with the office work and presentation. Okay, we are back in office. We copied all images in our project folder. We actually created 147 images, and you can see them here. I also prepare my GCP file so to get the accurate scale during the orientation process, because I measured 2 dimensions on a field which were perpendicular to each other. I could create some kind of local coordinate system. So the point number 2 is with 0, 0, 0 coordinate, and then 1 is 1.2 meter higher from the second point, and point 3 is 2.88 meters to the right side, so x-axis is 2.88, and the 2 other coordinates are zeros and zeros. So this GCP file helps me to orientate the model based on GCP points, but we'll have a look later on this in the software how it goes. What's next? Let's open the 3D survey software and start with a new project. Let me browse to my project folder, Ctrl A to select all the images, import them, and first we get a telemetry importer. I will select here EXIF data because it's a DJI drone. We'll use Slovenian coordinate system to have the correct units and so on. Import the data, and here we can already see transformed coordinates in our coordinate system, how high we fly. Actually we start about 2 meters and then go higher to 3.5 meters and then higher to 5 meters and so on. Let me close this window. This is our location on the map. If I will change it here to standard mode, I could zoom here additionally. As you can see, I've done most of the images from the same distance to the building and actually just keep on flying in a height, triggering every 5 seconds new image, then go higher, fly back, additional every 5 seconds, trigger one image. I actually stop doing the triggering images because in this case you get a sharper image. If you're flying and capturing images during the flight, some of the images could be blurry and so on. To have a better presentation, how I trigger the images, I can go to telemetry view. Not sure why the gimbal is pointing not in the right direction. Probably the initialization of the camera was not the right one. I could correct this in the software, so I need to correct my telemetry data. I will go to data, telemetry, manually set precision. Now this one, GPS in a camera offset, and I think the yaw needs to be 90 degrees. Confirm, close, once again back to telemetry, and now all my cameras are pointing in the right direction. This should be okay right at the beginning, but probably I need to actually calibrate compass on my drone, and probably the first one initialization was not the perfect one. But nevertheless, you shouldn't have those kind of situation. Now my cameras are pointing actually in the right direction. If we go and see how I actually trigger those images, that you will have a better feeling. You can see it right here. So I will just click on the first one and use my keyboard down button to move to the next image, and you see how I actually trigger images. So I fly horizontally and trigger every 5 seconds, or I think it was approximately 2-3 meters every second image. So one image, next one, next one, next one, and then I go higher and fly back and trigger images. So better is to trigger more images than less images. As you see, I assume on a field I will have 60 images, but now I have 147, but this is not a problem. The more images we have, actually better point cloud we should get, and also better texture 3D mesh. Okay, always take care to add something beside in addition, so don't stop here, go a bit further, so like so, and then of course back to the other side and also here, because you need to have also minimum overlap of 60% also on your side of your area of interest. Okay, in this way I did the mapping. Then at the end I actually go and add also some images with camera where the gimbal was pointing a bit down, like so, just to catch also all the details from those windows openings and so on, to have really good 3D point cloud. But probably this first set of images would be already enough. But to be 100% sure, I did also a bit of side images, so the gimbal is pointing here a bit more down. Okay, few close-up from some more details, and this is more or less everything. So we have images here. We are ready for first step, bundle adjustment. I will use the hybrid mode. It's the best one for most approaches. Probably this will be the only one mode in next version, because it's super stable, works nice. And let's start with the bundle adjustment. Because these were 12 megapixel images, so not big one, and I have a powerful laptop computer, this will be probably in 2-3 minutes. And after this we will already get a sparse point cloud, so actually we will see some basic model from our result. Here we can already see our result, and as we can see, most of the cameras are actually matched in the bundle. So we have 147 cameras in total, and 146 cameras were successfully matched. We see them here. Probably the one which was not matched was pointing somewhere else or something like that. Let's see. Where is this camera? Okay, here it is. If I check this image, okay, so looks like it was too close from two difficult perspectives. That's why it was not in the. That's why it's not in the bundle. But as we can see, we get a really great results already after the bundle adjustment. This is so-called sparse point cloud. Those cameras are already now orientated based on the bundle adjustment, and now we'll just improve the scale between objects with the help of orientation based on two known distances, actually our local GCP data setup. So that's why I'll go to GCP orientation, browse for my coordinate file, which is here, import it. Next step, because we don't have our 3D survey GCP targets, I need to deselect this one. And what I did actually on a field, I measured actually this distance, so the height of the window and actually distance between two windows with the measuring tape. This will help me to improve the scale of the model to get more accurate results. Even better approach for the orientation would be that I would measure, let's say, 4 to 6 points with a total station and use those 3D points for orientation. Or maybe even better that I will measure wider distances, so the complete building, not such a small distance. But okay, for the webinar purpose, this is more than accurate enough. We'll also get, I assume, super great results at the end, so not a problem. And let's start now with our orientation approach. I know here is point number 1. I need to select it from the minimap because they have the same X and Y value. I need to select those points here from the list. So point 1 in my case is this corner from window. Then I will select show the software point number 2, which one is here inside. Then the point number 3, select from the list, and I know it's here. So I actually measure my first distance, which was 1.2 meters, and my second distance was 2.88 meters. And I get the first estimation of the orientation What I will do here, I will switch to another image and repeat the process again because I don't have the GCP 3D survey targets. In the next step, I don't have an automatic recognition, and it really helps you if you select a single target on at least 2 or 3 images. Then less corrections will be done in the next step. And let's do the same way on this second image. So point number 1 is here, point number 2 it's here, then point number 3 is here. Okay, now I did this for 2 images. Let's go to the next step and see what kind of result we get. Okay, I'm actually already satisfied. A minimum correction is needed. More or less I need to deselect those cameras where the corner is not visible, and minimum correction to the ones where it's visible. I think here's again not visible. Let's smaller the images to have a better representation. Here is more or less everything fine, and the third point nicely visible, all those images, not here anymore. We have also multiple selection mode. I will check this checkbox and click shift and in the center of image and deactivate it. So this is the quick approach for faster deselection. Again, I can use this approach for this part. And now I think everything is done properly. When I go to the next step, I should get an orientation summary in short, so how accurate I actually select those 3 points. Because we have just 3 points, this will be probably accurate in millimeters, and in this way you can optimize your model in case you don't have a RTK drone. Mavic Mini has a standard GPS. We also get a message about the change of the focal length value, because the Mavic Mini drone is not in the 3D survey database. We read the focal length from the image and looks like the recalculated focal length is a bit different than which one is written in the image. But this is fully normal for that kind of camera. If you like to know a bit more, visit our forum, 3D Survey forum, and you have great explanation why this comes. And if you have a decent camera like Phantom 4 Pro or Phantom 4 RTK or Sony Alpha 6000, you probably shouldn't get this message. But nevertheless, we just agree on this one. There's nothing else to do. We see the difference in 4 to 6 millimeters, so it's super nice. I finished the orientation, and immediately the model is orientated. We can see those green points where the building is. We see the wall is pretty vertical, so everything looks great to me. And next step, what we need to do is reconstruction to produce a dense point cloud. We could do on high level, which is the best time performance, but because we have time and the images are just 12 megapixel images, we can go to extreme and click OK. And this will take now approximately 1 to 2 hours, depends on the graphic card you are using. I have a 260 RTX graphic card for laptop. It's powerful, definitely not the most powerful one, but let's see what kind of results we get in a 1 to 2 hours. Okay, here we have already our point cloud results, a bit more than 38 million of points with the help of 140 images. If I zoom in a bit, as you can see, it's super detailed. Even with such a small drone, we get stunning 3D results. I could read the name of the road from this table easily, and also all the detail is available here. Let me maybe show you also a high map view from the point, but yes, the better visibility is with realistic colors. So more or less everything is on in 3D. I could easily measure already some distances from this part, or I could start drawing 3D CAD lines with our CAD engine. But my next point is actually textured full 3D mesh. Before I go to this part, I would like to delete everything else what I don't need. The fastest way is maybe just selecting my area of interest. I will do like so, and then instead of delete selected, I will just click on delete other, and actually with a one click I actually clean up my point cloud. So delete other, click on clear to get the realistic colors back, and I'm already ready for the mesh calculation. So I will go to mesh, calculate new full 3D mesh. I would like to have also texture, calculation level, high is good enough. Let's set it to 4 million triangles, and I would like to have the full quality of resolution texture, because the orthophoto is our end results needs to be with a 1 millimeter of resolution. Let's use it full, because it's also a small object. This is not going to be a problem. If you would have, I don't know, 500 by 500 meters, then you will probably go with a texture resolution on half, in case you don't have enough memory. In my case, I have 16 gigabytes of memory. This is kind of a standard laptop, and I'm sure this will run with no problem. Let's click now on calculate, and this should take probably now 10 to 20 minutes, and let's see what kind of results we can get. Okay, and here we can see already our result of calculated full 3D textured mesh calculation. Super nice 3D model with realistic colors. Let's go and have a look about the details. There's nicely everything visible. So as you can see, the building is not anymore in great shape, so but we have a super support data for the restoration, so the professionals are going to be able to bring the building back to life with the same look as it was built 100 years ago or something like that. I think here is missing quite a lot of the stones and parts and so on, but I think on the other side of the facades we have enough detail that they can figure out what was actually here, but everywhere else I think it's everything there, so looks super nice. What we can do it here, so the result of this project is actually textured 3D mesh in the OBJ file format. Then this will be based for CAD drawings, where they can extract dimensions between windows, between different objects and so on. They could also prepare some kind of the 3D profiles. I will show you this actually with our bounding box tool, how it will look like at the end. So if I place two surfaces from the bounding box fully together, this is actually side view or side profile from the building. If you click shift and right mouse click, you can, control plus right mouse click, you can actually travel through the buildings and create this profile line from the building facade anywhere on the building. So all those options are actually available. Let's click on the reset view, and of course then the end result is also a building facade, so actually side orthophoto. So if I go to orthophoto, instead of selecting the calculate new top-down orthophoto, I will select on calculate new custom plane orthophoto, and then the digital orthophoto calculation custom plane pop-up came up, and what I need to do, I defined my orthophoto plane with the help of 2 points. I will just click 2 points on the facade to get the right position of my orthophoto box, And then with the right mouse on the box, I will actually extend my orthophoto to desired position. Let's hire also this orthophoto box. I don't need the orthophoto from the wall, from the roof. That's why this will be more than enough, but I need a bit more here down, like so. Also on the left and right side I have, I think, more or less everything inside. All the technical data are also written here. You can manually set the rotation angle or size of this orthophoto box, or you can save those positions for later approach. What's here super important is desired resolution is by default 1 centimeter. But as already explained, for this project we need an orthophoto from the facade with a resolution of 0.1 centimeters, so this is actually 1 millimeter. And I think I'm ready for calculation. Let's start with calculating, and now with the help of side orthophoto function we will create a facade orthophoto from texture 3D model with a resolution of 1 millimeter. Let's see, couple more seconds, and here is actually our result. Okay, so if I zoom in, you can see all the detail. It's really nicely visible, and in case we need to measure any distance here, for example, if we would like to calculate area from this specific window, we can easily click 4 points on the orthophoto and we have the area is 2.58 meters and so on. Or if you like to export this orthophoto as a, I don't know, let's say KMZ or JPEG of TIFF file to import it to AutoCAD or similar CAD software and draw out the CAD lines or anything like that, you could easily do. Okay, this was actually the processing workflow from images to site plane orthophoto, and I think we are ready with the data for documentation and restoration, and now the construction work can begin. Okay, hopefully you get a great feeling how everything goes. I think it's a super interesting, pretty powerful technology for those kind of purposes. I forgot to explain you when I was preparing for this webinar. I remember 10 years ago when we get one order to document such a great old building with a traditional way. At that time we had only total stations, and I think we spent 2 days to capture all the data. I spent 3 hours to generate a hand sketch and mark all the points which we measure with the total station, because we need to measure all those artifacts. Instead of 200 points, which is a standard surveying map, we created 1,500 points or something like that. And at the end, we need to connect those in AutoCAD or similar CAD softwares. So it was super difficult. These days we have new technologies available which help us to deliver better results and faster. So really fascinating about this project. Okay, we come to the end of this presentation. The questions and answers are here. My favorite part, and let me open just a quick question box so to see all your questions. Just a second. Let me copy them that you can also see those questions. I will just pop them here. So the first question was, Marco, do you take pictures manually, not automatically with the app? I actually use the automatic mode. You can set in the app, would you like to trigger camera every 1 second, every 2, every 5 seconds or something like that. And I actually did every 5 seconds. My advice is to stop just before the triggering camera. In this case, you will get really the best possible result, and the image is not going to be blurry. So I use, in my case, actually 5-second interval. Then Next question is, Marco, there was a little bubble in the mesh in the side of the window. First level, how can we avoid this? So yes, this bubble was created with the full textured mesh calculation because there was some probably noise in the point cloud, or I didn't map them fully detailedly from the side part. I just need the front page of the building, let's say like so, and that's why this bubble was there. What I could do to eliminate this is just delete points which were there, and this bubble wouldn't be created, or later on just select them with the select tool and delete it out, so it's not a problem. I did it fully automatically, so I didn't spend no additional time to clean out the point cloud and so on. Okay, hopefully I answered to your questions. And then Chris is asking, what would be the effects on the model if the camera orientation wasn't correct? Okay, so what I actually did first time I did the calculation of this example was I wrongly selected the position of first point, not on the outer side of the windows, but from the inner side. And because those points were not then on the right plane, the model was actually a bit wrongly orientated. So you would probably immediately see that there's something wrong with the model. So wouldn't be so vertical, or would be rotated beside or something like that. So yes, take care and definitely do the orientation properly. When you do those kind of orientation with the 2 dimensions of perpendicular plane, it's great to have them all in a horizontal position, or have those points in the fully vertical position. So this is super important here. Okay, I answered all my questions. If there are any more, please feel free to send them to our support@3dsurvey email, or contact us any other way. The webinar was recorded. You will get the recording. Happy to see you in another 14 days, I think, where we have next webinar. So feel free to watch them and contact us if you need any help. Thank you for listening. Bye.